Hello and welcome to PT and Nutrition Education's e-learning platform. Today we are continuing with our preparation for the examination in anatomy and physiology, and as you can see, today's focus will be about the respiratory system. So if we're going to look at some of the objectives in the content of today's video and today's lecture, you can see that we're firstly going to identify the locations of the key structures of the respiratory system. Then we're going to look at some of the key functions of the respiratory system and how that pertains to some of those key structures, to describe the process of gaseous exchange, and then to look at the mechanisms of breathing. Now, just like the previous two videos in the skeletal system and the muscular system, you will be required to take part in some interactive tasks that are both on our website and also in the work booklet which you can download, and we expect you to do that prior to starting this lecture. You can find these underneath this video on the links highlighted on the website. So without further ado, let's get cracking on the respiratory system. Okay, so the first objective relates to the structures of the respiratory system. Now, just before we go through these one by one and go detailing some of the functions of these structures as well, I want you to test your knowledge and show us what pre-existing knowledge you already have. There is a task on the website which is under task 3.1. So if you click on that on the website, it will take you to an interactive task where you can link up some of the key structures of the respiratory system and test yourself before we've even been through it. And of course, once we've been through it, you can also test yourself again to see some of the learning that's taken place over this objective. Okay, so pause the video, complete the task, and then we'll get cracking on the structures of the respiratory system. Okay, so the first parts of the respiratory system that you need to be aware of are firstly structures which are tasked with getting air in to the system. So of course we've got here the nasal passage, and as you can see we have quite a large area in which we can breathe in oxygen in order to get this into our respiratory system. And of course we can breathe in through the nose via the nasal passage, and also through the mouth, which is known as the oral cavity. So that's our first two points of entrance for the gases that we breathe in. If we go down just one more and we look at the pharynx, this is also known as the throat. So this is essentially just the back of the throat, and this is really just the next step in which any gas will continue its journey into the lungs. So the nasal passage and the oral cavity provide those entrances for oxygen to be delivered to the lungs, and it's the pharynx, which is also known as the throat, which again provides just one of those step-by-step structures in which air has to pass through in order to get to the lungs. Now, for the rest of the structures, we're going to zoom in a little bit more on the next slide. Okay, so zooming into some of the structures of the respiratory system, the first one I want you to pay attention to is what's known as the larynx. Now, the larynx comes after the pharynx, and this is where we harbour our voice box. So the larynx is actually covered in very tough muscle fibres in which protect the voice box to maintain its integrity. The next structure down is what's known as the trachea. So you may know the trachea as the windpipe, and this just simply provides an airway into the left and the right lungs. Now, of course, we don't want the trachea to be damaged in any kind of way, so the cartilage rings which surround it are very tough and help it to maintain its integrity should there be any type of damage. Once we go down from the trachea, we then enter into both the left and right passageways. So the bronchus, or the bronchi for plural, is the structure which divides the left and right lung. So if we think of the trachea as the main trunk of the tree, it's the bronchus or the bronchi which then divide into the smaller branches. Now, as we go into the lung from the bronchus, you'll see that those branches further divide into smaller branches which are known as bronchioles. So the bronchioles essentially just divide so that we can increase the surface area by which we deliver oxygen and remove CO2. At the end of those bronchioles, we have air sacs called alveoli, but we'll focus more about those alveoli, those air sacs, when we talk about gaseous exchange. When it comes to breathing taking place and the muscles that are involved, there are two key muscles which you need to be aware of. The first one is what's known as the intercostal muscles. So these exist between the ribs and allow the ribs to move up and out and down and in, depending on whether we're breathing in or breathing out. And the same goes for the diaphragm muscle, which is a key muscle when it comes to inspiration and expiration. But we'll talk more about that when we discuss the mechanics of breathing. Another structure that you need to be aware of is what's known as the pleural membrane. So the pleural membrane is essentially a protective layer which encases the lung. And then we've got a pleural cavity. Now the word cavity just means a space or a hole between the lung and between the pleural membrane. So of course, when the lung inflates with air and then deflates in order to decompress, it's the pleural cavity which gives us that space in order for the lungs to fulfill their role. Another structure that we haven't mentioned, although it's not primarily to do with the respiratory system, we do find it amongst the respiratory structures, and that's what's known as the epiglottis. So the epiglottis is a flap of tissue which covers the trachea whenever we swallow food. So to make sure that any food doesn't go down into our trachea, it's the epiglottis, which is the flap of tissue which will cover the entrance to the trachea so that any food does not go down into the respiratory system. Okay, so now that we've been through the main structures of the respiratory system, you've done the task 3.1, which of course you can try again now we've been through these structures, and as well you've watched the video which you can find the link for on the website. You should be nicely prepared to complete the formative assessment which you can find in your work booklet. So the tasks look like this. You simply have to again name those key structures. There is a missing word task which you can fill in the missing words for, and then as well the review of the respiratory structures in which the flow of air, so step by step, what are the structures which air passes through in order to get all the way to the alveoli. So I'll give you a few minutes to complete that, pause the video, and then we'll continue with the next objective for the respiratory system. And the final structure is what's known as an alveoli. So an alveoli is an air sac which we find at the end of the bronchiole, and this is where a process known as gaseous exchange takes place. We'll talk more about gaseous exchange in the next slide, but for now you need to know that there are around 300 to 500 million alveoli at the end of your bronchioles. And of course, this allows us to get oxygen in and CO2 out. In fact, we have so many alveoli that if we were to lay them one by one, it would cover the area of a tennis court. And if we were to lay them one by one in a line, it would cover a distance of about 620 miles. So it's fair to say that we are equipped with a lot of alveoli in order to get oxygen in and CO2 out. Now, just to finish off the structures and the roles of these structures within the respiratory system, there is another interactive task which you can find on the website under task 3.2. So click the link, go to the task and match up the definitions to the different parts of the respiratory system. Once we've done that, then we can move on to the next objective, which is gaseous exchange. So pause the video, complete the task, and then we'll move on. Okay, so the second objective of the respiratory system relates to gaseous exchange. First off, the process of gaseous exchange is very simply just the exchange of oxygen and CO2 between three different structures. So this is the passing of oxygen and CO2 between the alveoli and the capillaries, and of course it's the red blood cells which offload those individual gases. Now, the way that those gases are able to exchange is through a process known as diffusion. And this is very simply the movement of gas from an area of high pressure to an area of low pressure. So if we take inspiration, for example, where we're breathing in a new batch of oxygen and we take it from the trachea into the bronchioles, into our alveoli, then the pressure in the alveoli is higher than it is in the capillary. And because of this, the process of diffusion means that oxygen will now travel across the one cell thickness of the alveoli and the one cell thickness of the capillary, which makes it very easy for diffusion to take place, and oxygen will then bind to the red blood cell. And that process by which oxygen has literally jumped from one tissue to another into the red blood cell is known as diffusion. And the way that they're able to do that is because of the transient partial pressures of the alveoli and the capillaries that are ever changing every time we breathe in and every time we breathe out. the change from high pressure to low pressure therefore changes this intimate relationship between oxygen and CO2, which is being transferred through the process of gaseous exchange. The same applies for CO2. So when we are offloading CO2 from the red blood cell, which at the moment is deoxygenated, then the pressure of CO2 within the capillary is higher than that of which is in the alveoli. So therefore, this high pressure of CO2 will diffuse again across those single cell membranes into the alveoli, and then of course we expire that CO2 and get rid of it through expiration. Okay, so just to consolidate the process of gaseous exchange, there is a section in the work booklet that you can access and just fill out the step-by-step process by which gaseous exchange takes place. Pause the video now, spend a few minutes completing that task, and then we'll move on to the next objective. The mechanics of breathing, of course, have got two processes, and that's inspiration and expiration. And there are a whole host of happenings during inspiration and also expiration with regards to the lungs and the respiratory muscles, and also the skeleton and how they all interact in order to get air in and also to get air out of the body. What you need to be able to understand is the role which each structure plays when it comes to inspiration and expiration. So we're going to go through these structures one by one and identify the roles which they undertake during both inspiration and expiration. So the first one, as you can see from the bullet point list, is the diaphragm. And the diaphragm during inspiration contracts. Now, when we're trying to inspire air, we're trying to create as much room as we possibly can. The more room that we can create, then of course the more air that we can get into the respiratory system, and hence more oxygen into the circulatory system. So the diaphragm will actually contract and lower in order to create more space for the lungs to expand. So the diaphragm's natural position is actually high when it is relaxed. When it contracts, it physically moves down. The external intercostals, which are again attached to the ribs, contract, and these help to move the ribs up and out. So the ribs will move up and out in order to create more room in what's known as the thoracic cavity. Now, the thoracic cavity is simply just the space in your thorax, and its name is given because of the thoracic spine, or the section of the thoracic spine, which we learn during the skeletal system. And the volume of the thoracic cavity, because the ribs are moving up and out, and because the diaphragm is contracting and moving down, increases, and therefore we're able to get more air in. Now, of course, partial pressure plays a role here as well, because the lungs' air pressure decreases below that of the atmospheric air. This means that air is going to rush into the lungs because the pressure that we've created inside the lungs is lower than the outside atmospheric air. And this pertains to the rule that we learned on the previous slide, whereby air or gas will always go from high pressure to low pressure, and hence this completes the process or the mechanism of inspiration. So the opposite mechanic of breathing to inspiration is of course expiration, and as you probably already guessed, all of the processes and structures, the roles that they undertake during inspiration, of course, are reversed when it comes to expiration. So again, if we try to think of this logically, with expiration we're trying to push as much air out as we can, so we're therefore trying to decompress and squeeze as much CO2, of course that's the byproduct which we're trying to remove from the system, as much as we can. So the diaphragm is relaxing. Now, as mentioned on the previous slide, the diaphragm's natural position is actually up high, so when we're expiring, the diaphragm will relax, the muscle moves up and therefore compresses and puts more pressure on the lungs to expire. The intercostals, which again we find in between the ribs, this time now they are relaxing. So rather than moving up and out, the ribs are now moving down and in. So with the diaphragm pushing up and with the ribs moving down and in, this means that the thoracic cavity is decreasing. So we are compressing that space and therefore squeezing air out of the system. And again, partial pressure is playing a role here because we're creating this pressure inside the lungs. It is over and above that of the atmospheric air, and therefore because we know that gas or air will always try to find areas of low pressure, air will be expired from the lungs. Okay, so just to put some of that knowledge to the test now, there is a task in your work booklet on inspiration and expiration and some of the roles which the structures undertake during the mechanics of breathing to help you along and revise for the exam. So again, pause the video, complete the task, and then we'll move on to the next objective. And the final objective we need to cover for the examination relates to the respiratory volumes. So there are 6 respiratory volumes that you need to be aware of. You need to understand what each one of them means via a description and also what some of the amounts are at rest. So if we look at the first one, which is breathing frequency, this is very simply just the number of breaths that you take per minute whilst at rest. And we take, and of course this may differ between different individuals, but generally it's between 12 to 16 breaths for your average adult. Tidal volume is the volume of air that we breathe in or out per breath, and this is generally around about 500 millilitres or 0.5 litres per breath. Now if we times the breathing frequency by our tidal volume, then we get what's known as our minute ventilation. So this is the volume of air that we breathe in per minute. So of course if we times 12 by 0.5, which are the general values, then minute ventilation is around 6 litres of air per minute. Vital capacity is the maximum amount of air that you can forcefully inhale or exhale in one breath. So you may have done this test before at the doctor's via a peak flow meter, where you breathe forcefully into a tube and it will measure how much you can actually inhale or exhale. And generally it's around the 3 to 5 litre mark. This can improve massively, especially with aerobic based athletes, and also people that are quite tall generally have larger vital capacities simply because they have larger lungs. Total lung capacity, all of the air in the lungs after a maximum inhalation. This is around 6 litres or 6,000 millilitres. Residual lung volume relates to the amount of air that is left in the lungs after we've forcefully exhaled. So there is always a fail-safe in terms of keeping some air within the lung to make sure that they don't collapse. So the amount for that is around 1.2 litres or 1200 millilitres. So those are our respiratory volumes, and once again there is a task in your work booklet that you can fill out just to revise and recap some of those descriptions and also some of those resting values. Okay, well done. So that's the respiratory system complete. We've covered all of the objectives that you can see there below. This is a little bit shorter than the skeletal system and the muscular system. Nonetheless, it won't hurt to revise and recap all of those objectives we've been through. So once again, there is a formative assessment that you can access via the website. So just click on the practice assessment underneath the respiratory system video and then complete the 10 questions related to the respiratory system and the objectives covered. Good luck, and we'll see you over at the next system.